Hello, my brothers and sisters. Today I am changing things up a little bit. So instead of me talking about my own goofy ideas about life and and stuff, so I wanted to make a summary of and a review of this book called "How Emotions Are Made: The Secret Life of the Brain," written by Lisa Feldman Barrett. It, as you can tell by the name of the book, it was a very interesting read. Uh, it talks a lot about how emotions actually, what they actually are, and how they're produced, and it also like deals a lot with a lot of the misconceptions that are flourishing around, especially in and also in the scientific community about emotions and what they are. So even so, Lisa Feldman Barrett is of course a doctor and or professor in this field, so she knows a lot, but at the same time it's a quite radical book, since it takes it takes a quite radical stance in regards to what emotions are. Um, so I will in this video I will try to make justice to the book and give a not quick but a review of the highlights of the book, which I think is in the first part, the first half of the book, when they're actually talking about how the emotions are produced inside the brain and how they're related to our concepts and stuff like that. So so let's get to it. So this story starts with a book, not this book, another book that was written. This is supposed to be a book written by Charles Darwin, the father of evolution, who we all know. And so the book he wrote was called The Expression of the Emotions in Man. I hope you can read what I'm writing here. The Expression of the Emotions in Man. And since Darwin was a person with a lot of status in the scientific community, or in the community in average, what he said in this book about emotions kind of laid a foundation for how we perceive emotions from then on. And the proposition he has, basically, I haven't read this book, so I'm kind of just portraying what Lisa Feldman Barrett I read in her book about this book. But according to her, what this book portrayed was that emotions are like fingerprints inside of our brains. So fear has a certain fingerprint in the neural network. Anger has a certain fingerprint, and this book then gave rise to what's called essentialism. So what essentialism is saying is that it's kind of saying that emotions have a certain essence. and the reason she thinks that this essentialism has continued to flourish during the not only the 19th century but the 20th century as well is that feelings or emotions, they feel like automatic reactions in our bodies. So there's two reasons for essentialism to live on this idea, which is a kind of misconception, according to Barrett, that emotions work this way. But the one misconception is that, or the reason that it lives on is that feelings appear as triggered. So when someone scares us, or someone makes us angry or sad or happy, we immediately feel the emotion. So it is as if someone triggered some network and kicked something off that came to life in us. The second reason that essentialism feels natural is also that we classify our feelings in categories, right? So when we say I felt anger, we can have different nuances on this feeling, anger, but it could be that I dropped a stone on my foot and it hurt, or it can be that someone took my precious bunny as a kid away from me and I felt anger. So I can feel anger in different ways, but there is a kind of essence we're looking for when we're grouping all these feelings of anger together. So that's also so our classification of feelings is also a reason for why we believe in this essentialism. So these are the two reasons for us to continue to think that essentialism is the way emotions work, and this belief still continues. Is still alive and well today in many academic circles even. So since we have this misconception of feelings, this has also led the scientific community to look for feelings in the wrong places. So 1930, they were making some experiments with some monkeys. This is supposed to be a monkey here with a little tail and some foot. So these were called rhesus monkeys. They did some not so nice experiments with these monkeys. They removed their amygdala, and the amygdala is what people often associate with fear. So they wanted to see what happens if we remove the amygdala on rhesus monkeys, and as they were, so the hypothesis was that if they removed the amygdala, these monkeys would not feel fear anymore, and that was actually what happened. These monkeys started to show no signs of fear. They could do things that other monkeys were afraid to do. And So this kind of strengthened the removed amygdala. Amygdala. So this strengthened the belief in essentialism, and but later, a couple of years later, they did. They were making studies on a person called. They don't mention the patient's name, but there is this disease called Urbach. I cannot pronounce it. Urbach Viet. Urbach Viet. And this is a genetic disease which removes or destroys the amygdala of a person. So there was this patient called SM in the studies who had this disease and whose amygdala was completely gone. So they wanted to confirm that this amygdala is also the source of fear in humans. So they did a lot of horrible experiments with this poor SM. They were letting this person watch horror movies. They were torturing him or him in different ways, and as they were out to prove this person seemed to not show any fear at all. So this was also kind of confirming that fear was very associated with the amygdala. But they did at the end an experiment where they filled the room with carbon dioxide, and this led to poor SM to have a panic attack, because that person couldn't breathe anymore. So this kind of threw off the whole idea that the amygdala was necessary to feel fear. This person had no amygdala and felt fear, so obviously this couldn't hold anymore. So this led to two new insights about emotions. One is called degeneration, and the other one is called core systems. So I'll make a cloud. I'll make a cloud down around this. So this is the insights about. So degeneration is the proved that many neural networks in the brain can generate one feeling. We don't need to have the amygdala. The other networks in our brain can create fear, and the core system is that we can have one set of neural networks in the brain can contain many purposes, not just one. So this degeneration is telling that many systems or many neural networks in the brain can make up for example, if this network is lost, then this network can take over the role that this network was serving before. So this is like many to one, and then the core system is when we have one system that has many purposes. So it can be the amygdala maybe is not just for fear. It can be for maybe for happiness as well. Right. So we have one to many here. So as you can see, the brain is more shapeable than what people believed before. Yeah. So that's a little bit about how things went on from that point on. So what the author is proposing is that emotions are actually not triggered. Emotions are constructed by our brain. Oh, sorry. The emotions are constructed by the brain. So our brain is much like a computer, which is all the time making simulations. It's running hypotheses. So it's running hypotheses for about the world outside of it, and making experiments and simulating and trying to confirm its results. You can view the brain much like a scientist actually, who is testing the reality and seeing if its hypotheses are accurate or not. So our brain is doing it not just for our outer experience. We will see how it's also doing this for our inner experience. So what Barrett is proposing is the theory that she has regards to emotions is called the theory of constructed emotions. This theory, I will explain it further, but to give it a quick overview, it's saying that emotions are simulated. They are simulations. And these simulations leads to meaning for our experience. That's the reason for them to come to life. So they give meaning to experience. And when we have meaning, we can act on our experiences. We can take action. So the two main ingredients that she uses for her theory is the core system we talked about before. So this is like the ingredients of the emotions. This is supposed to be like a cookie. So we can have different flavors in our emotions. So one core system mixed with another core system can create, for example, the feeling fear. But if we mix it up with another core system, we can have maybe have a bread leaf, instead of a cookie, we can have a bread leaf. Like this is maybe fear, and if we add some other ingredients, we can have joy, maybe. So the core systems are like the ingredients, and these feelings, they are culturally they're culturally transferred. Culturally transferred. So we transfer this. So emotions are kind of like concepts according to this theory. So we transfer them to our children, and we learn them by watching television and stuff like that. But they are not. They are nothing. There's no essentialism behind them. We are learned. We learn. We are taught. Sorry, we are taught the feelings or the concept. So how there's some proof of this. So there is for example, in Micronesia, there was this people called they're called Ifaluk. Ifaluk. And according to the Ifaluk, the feelings are not something in one person. It's a feeling. It's actually more of a dance between two persons. So, according to the Ifaluk, you cannot feel anger or sadness by yourself. You feel it as a dance with someone else. So this also brings to light that feelings is actually something cultural. We can learn feelings in different ways. It doesn't. Our Western cultured perspective on feelings is not the only one that's out there. So yeah. Okay, so now comes, according to me at least, the more interesting part about from the book, and it's how do feelings, because we feel the feelings. We don't just, they're not just concepts in our head, anger, or we actually feel something emotional. There's some substance to our feelings. So how is this substance created? So yeah, so how do sensations come to life in the feelings? Yeah. Okay. So, like I said before, the brain. Let me draw a brain here. It looks like a cloud. It's supposed to be a brain. Let's make an eye here. So, and a nose and a mouth. So we see this is supposed to be a brain. Yeah. Looks like an alien most. So our brain is all the time making predictions, like I said. It's this simulation that it's making of the outside world is built on concepts, right? So a simulation is like a pre-built. The concept is the simulation, and then we verify the concept or the simulation with what we see outside of the world or hear outside of the world. and we also use our experience to make predictions with our concepts. So when we're so let's take a look at this simulation, how it acts, or how it works. So like I said, also the simulation not only goes for the it goes both for the inner experience but also for the outer experience. So let's start with the outer experience. So if we see something outside of our vision, let's say we see a chair or something, when they had done studies and recorded the activity of the brain, what happens is we get some signal inside, input signal. It passes what is known as thalamus, and from thalamus it goes on to this area of the brain called the visual cortex. So we see 1% of all activity when we're looking outside. 1% is from the eye back to the visual cortex. But what's interesting now is that when we're looking, this is just 1% of the activity. 10% of the activity comes from the visual cortex back to thalamus. That's around 10%. This is approximately numbers. And here comes what I think was very astonishing reading the book. But the majority of the activity was from was coming from the rest of the brain here. So this was around 90% of all activity is from the rest of the brain reaching the visual cortex. So when we look at it, we look at the numbers, this is from outside, from the eye, 1% of activity, and this is from inside, 90%. So when we're looking outside, we can actually quite confirm just by looking at these numbers that what we're seeing is actually, it's like the movie Matrix. We're not seeing reality. We're seeing what our mind is telling us to see. Yeah, it's just 1% that is the actual input. So yeah, so let's go a little bit to the side, or no, let's go down here a bit. And so our brain is making predictions in what's called a prediction loop. And from this, it's making a prediction, then it's running a simulation from that prediction. So it believes something, and then it tries to simulate that. So creating a model of the world, a concept. So it believes it's looking at a chair, so then it's building the model of a chair and simulating it, and then it's comparing this concept, this model, with with the input. So it's comparing the model with input. Is it matching or not? And well, depending if it's matching or not, it will create error resolution. So it will solve the error if there is a error. Maybe it was not a share it was looking at, it was actually a dog or something. So then it will create a new prediction based on this error and try to make a new simulation, a new concept that matches what it's looking. Oh, it was okay, so now it will try to simulate the model of a dog instead and compare with the input, and until it reaches consensus or reaches a satisfying concept. So what can happen here is it can either it's making it's just listening, it's ignoring maybe the input and just considering the concept. So when we're dreaming, this happens. We're not listening to the input from our senses. We're just listening to the prediction and to the model, the simulation in our head. There's no input. The other extreme is that we're only listening to the input and ignoring totally the simulation. For example, when we're meditating, or as I have heard, when you have an LSD trip, this can also happen. So now in this state, you're totally ignoring the simulation, only looking at the input. And in between these two extremes, we have what's called learning. So the experience can be either completely. So here we're listening to the input, and here we're just listening to the model. And normally in our daily life, we're somewhere here in between these two. Sometimes we're maybe relying more on the model, sometimes we're more relying on the input and very focused. Yeah. So what does this what does this have to do with what does this have to do with feelings? We're talking about feelings. So let's me draw a new brain here. So inside of our bodies, I will make a little nerve here. So here let's say this is the heart. And we also have I think we have some lungs here. I don't know. I'm very sorry if I not make you understand. Maybe this is the liver. I'm not sure if it's there, but we have many organs in the body. We have some kidney here. I think it looks like a bean, right? So all our internal organs is connected to the brain through what's called the vagus nerve. So this is a very important nerve. It's connected to the heart, to the liver, and to the kidney, to everything in our body. Every organ in our body is connected with the vagus nerve, and this vagus nerve is connected to what's called the interoceptive network. So let me. This is of course a abstract drawing. The interoceptive network does not look like this, but there are parts of our brain that's connected to this vagus nerve. So let me just write the name of it. Interoceptive network. Yeah, so the interoceptive network is taking information from the whole body, and it acts like a financial department in a company, that it's taking the accounts of all the different departments in the body and seeing if the balances checks out, if maybe the lungs are spending a lot of energy, right? And this person hasn't slept for 2 days, and the lungs are agitated and breathing heavily. But the interoceptive network will then it will create a little report. So out comes a little report. This is supposed to be like a paper from a printing machine. The interoceptive network is the printer here. Yeah, so it prints out this report, which tells the brain how is the body feeling, how is the energy, is everything in balance in the body, energetically, in an energetic sense. So this report tells us 2 things. It gives us energy budget, and it also is the way it's portrayed is through something called affect. So affect is a sensation. So this is how it is. If you're tired, you haven't slept for 2 days, and you're running, and the interoceptive network is seeing that your lungs are working very heavily and needs a lot of energy. Your heart needs energy, and it's kind of seeing things that it's not checking out the energy balances. So it will create an effect that makes you want to go to rest. So affect is the key word here. Affect it's not an emotion. Affect is something that you have in your body all the time. So as they model it in the book, affect is consisting of 2 dimensions. One dimension is arousal, and the other dimension is pleasure. So these 2 dimensions, arousal and pleasure, gives the summary, or the affect summary from the interoceptive network. So let's say that this person now that's running and haven't slept for 2 days, probably the body, the affect will lie not on this is high pleasure, this is when you're feeling good, this is when you're feeling bad, and it will also set into effect a low arousal probably. So you feel this is when this is, we can say here, unhappy, and this is when you're feeling good, and this is when you're feeling bad, kind of. Let's say you feel bad, and here is when you're excited, and here is when you're tired. Okay. So now that you're this person is running and haven't slept for days, we maybe will put the affect down here, and we will put somewhere here in this area. And we can look at another example is when the person is let's change color here for. So when another person is have slept very well and is kind of sitting still and have a lot of energy, maybe the affect will wanting to put the person in this area somewhere, maybe very around here, with much arousal, excited, wanting to go out and do something. Or maybe it will be here, so he feels bad, so he needs to go out and do something. So if he's feeling good, maybe he will not go out and do something. You see, so this circumplex, or can tell. We can put a person in different states of mood. So affect is kind of like the mood you have inside of your body all the time, and this doesn't go away. This, you have it throughout the day, different affects. So this reporting, this report is being produced continuously from your body and telling you, guiding you what to do. So when you're here, when you are excited and you're feeling bad, here maybe it's when you have anxiety, and here is when you're feeling bad and tired, you're kind of depressed down here. Here you're tired but you're feeling good, so here maybe when you're calm. And here when you're here you are excited and you're feeling good, so it's maybe when you're excited and happy. So this affect is really important for our feelings. So the interoceptive network is creating a prediction from within the body, what it sees, how the organs are working, and it's giving it's not only giving this prediction and affect, it's also deciding when to produce glucose, for example. If the body is it's predicting that it needs more medicine, it's also or needs more energy, then it's also producing a prescription and pumping out hormones in the body. It's doing a lot of things, this interoceptive network. But affect is the king in the body. Affect is, which is produced by the interoceptive network. This is, it's sitting in the driving seat of the car. Affect is kind of like the king in the head. So previously, people still have a misconception about the brain, that we have this neocortex around the brain where our cognition resides, and this cognition is kind of is the king of the castle and knows. So I thought we can think ourselves out of a depression, or we can think ourselves out of like anything, but actually it's not that way around. Cognition is in the passenger seat. It's affect who is driving the car. So the affect is creating what's called also affective niche. Affective niche, I think it's called. No, yeah, I'm not sure. Niche, I don't know. But this affective niche is telling your brain what to focus on. So for example, if you have a fever, your affect will be like I have right now actually. Your affect will be quite low, and you will not have that much energy to do anything. Even if someone calls, come and we will play football, we want to play soccer now, I will go, no, my affective niche is forcing me to lie down. I cannot do anything else. So our brain is constructed to anatomically, it's constructed to let affect override any other decision of the brain. So even if your cognition, you can understand, I should do this now, affect will it will guide your attention to what you need to pay attention to. So yeah, so we're not as rational as we would like to think. Okay. So yeah, so the interoceptive network is relying a lot of concepts. So it's relying on the concepts that we're creating when we're looking outside in the world, but also the concepts of how we're feeling inside of the body. So concepts is really important. Let me talk about that for a while. So concepts have three characteristics. They're changeable. So a concept, let's say a concept tree, for example, we can learn new things about trees. Maybe that, there are actually trees that grow roots in stone, let's say. Something I just are inventing here, but we learn something new about trees. So we change our concept about trees. Maybe, and another characteristic of on concepts is that they are context dependent. So depending on the where I see the tree, if I'm looking at it at a painting, I will perceive the tree as one thing. If I see the tree in a house during Christmas, I will perceive that tree from the context in a different way. So concepts are also context dependent, and they have they're goal based, goal oriented. So I can look at a tree and I'm freezing, so maybe I see in that tree I could chop that tree down and make a big fire, and so I can hold myself warm. Or I can see a tree when I see a dog chasing me. Oh shit, that tree I can climb up and protect myself from the dog. So I can have different goals with the concept as well. So concepts. I misspelled it. Concepts. They are in our brains. They are all the time competing with each other. So we can have it's like they're making a race. Which concept will come to the finishing line? Maybe we're looking outside and we see something, we don't know what it is. So we will run different simulations in our heads. One simulation is maybe it's a dog, another it's a cat, maybe it's a car, and another it's a person. So the concept that comes closest wins. Maybe it was a cat, so this wins. So they're competing with each other, the concepts. So they're competing. And and a concept, we can also think of it like emotions, because emotions are also concepts according to the author. So we have anger, we have happiness, we have joy, we have sadness, and we're competing which emotional concept is closest to the truth of what's going on right now in our lives. Okay, and the one, maybe it was joy that won, but so these concepts, dog, cat, car, person, they are experiential concepts, but we have also mental concepts like emotions, happiness, joy. We cannot point at joy outside of us and say that's joy. Well, if we see a lot of people happy, we will kind of draw a conclusion. Okay, that's kind of what happiness looks like, but it's mostly a mental concept. We have other mental concepts like addition. Addition is nothing we can see outside in nature. It's a pure mental concept. So certain concepts need words to explain them. This is an ear, and this is a mouth talking, and this ear is listening to and learning the concept. Because the thing about emotions is that they are statistically irregular. Statistically irregular. They are not. Happiness can look in many different ways, right? So we have to use words to transfer the concept from one person to another. We cannot just draw on many examples. We have to explain it with words, what happiness is. So concepts are really important when it comes to emotions, because that's what emotions are. So this so how does these concepts, because I'm saying they are used to predict, right? They're used in the simulations of the brain to predict what's going on and to understand what's happening in around the world, around our world. So I will draw a little network here. Bear with me. I will draw like 5 of these layers. And then I will draw here even smaller dots. Okay, I think this is enough. And from this there goes to all, and this goes to all. I will not draw everything because it will take time. Yeah, I will draw something like this, so it because it would be crazy if I have to draw from all of them to each one. Okay. So this is also the brain, a network in the brain. So let's draw an eye here again. So when our eyes are looking outside, this is kind of the first neurons in our brain in connection with the eye. So here we're perceiving kind of colors maybe. And here in the next level, here this neuron is connected to all of these neurons. So here maybe we can perceive lines So now we can draw a conclusion. This neuron can create shapes of what we're looking at. and this, on this level, this is connected to all the other neurons here. So here we can kind of interpret what the lines are doing. This is maybe a circle we're seeing, or a square. And now you see, and this neuron is connected to all these shapes, and it can draw a conclusion of what it is. This is maybe a share it we're looking at, right? So we start by, it gets more and more complex the more we go to in this direction to the left, the more information we can start to draw. And this is of course it's a simplification of our very very simplified version of what's happening, but it shows you in principle what's going on. So these neurons are closer to the outside, and these at the left here is more to the right we have what's called the multisensory summary. So here so here is where the concepts are relying, right? So here we can kind of say, okay, what we're perceiving, it's a storm outside, or right now I'm on vacation and I'm on drinking a piña colada on the beach. I can have concepts, full concepts of what's going on from just seeing colors and lines. We go to this direction and we have a multisensory summary of what's happening in the world and inside of our bodies. So this multisensory summary layer of our brain resides in the interoceptive network. So this means that the multisensory summary layer of our brain is capable to also deduce what feelings, making a summary of what feelings we're feeling right now as well, not only what we're looking at outside of. So you see why the interoceptive network is so important. It's like where all the good information is lying in our brains. So when we're small children, let me erase this. So when we're small children, we're learning, right, about the world. So we're building concepts. So we first learn what colors are, then we learn what lines, then we learn shapes, then we learn tools and stuff, and then we learn whole situations, what they mean. So here we're building concepts creation, we can call it, when we're small children. And then when we're adults, we can use these concepts that we learn to apply them. So now we can predict what these neurons will be, and these neurons and these neurons. So when we're going this direction, we're creating predictions with the help of our concepts. Predictions. So we take the concept share, maybe it's in this neural network, right? So then it will predict what kind of objects it will see in the room, what kind of shapes they will rely on, and if everything is correct, this will all match up, right? If this neural network was correct in its guess then it will kind of predict what this eye will see when it's looking outside. So that's how the magic happens. So how the and I was telling you that concepts were competing with each other, right? Which concept will be the winner? Will it be this concept, or this? Which will predict the bestest fit of all of these neurons? So the prediction is or the mechanism that decides which concept that wins is called the control network. And the control network, it's not like it sounds. It's that it's controlling anything. It's mostly, you will see that it's mostly optimization it's doing. But when we see the letters like this, A, let's see. Let me draw this like this. What you see here is the letters A, B, and C, right? But if I write like this, now you see this becomes something else. So now you have two contexts that are competing with each other. This context wants this shape to become letter B, and this context wants it to be number 13. So what the control network is doing inside your brain is based on the context. It's trying to decide which is the winner, and it's doing that by seeing which connections is being mostly used in so maybe it's seeing that this is used a lot, and this is used a lot, and this is used a lot, and this, but and this one and this one, but these ones are not being used. So what the control network will do is kind of kill them off, kill all the connections that are not being in use. And so it's deciding which one is the winner. So it's kind of optimizing and seeing, okay, this one is used a lot, so, and this one is not being used, so let me remove this unnecessary connection. Yeah, just so it's very important for the brain to have a lot of concepts, so it can make better predictions, right? So the more concept it has, the faster it will be in predicting things, and it will also be faster it will cost a lot less energy as well, because we have to remember this is using a lot of energy to create all these connections. So it also has a metabolic cost to make these predictions. Okay, so I will kind of wrap up now with my last the last chapter about social reality. So we have seen now the brain is quite complex, and it's making our emotions. It's making emotions are like, from what I see it as, tools to predict what to do. So something happens to us, and based on our experience, we will create or construct an emotion that explains what we're feeling based on previous experience and concepts that we have. Okay, so this person behaved like an asshole to me. That's what my brain is telling me. So I need to do this or that. I don't know. and I need to cry maybe. And so the concepts are there to, the emotions are there to create meaning to our experience, and to make us use help us to make appropriate responses to what's going on. So emotions, are they real? Are emotions real? So let me start by asking you this question. Let's see, if we chop down a tree in the wood, in the forest, we chop it down and it falls, and it makes a sound. But if there is no birds, there's no animals, there's no human, it just falls down in the wood, in the forest. Do this tree make a sound, even if no one is listening? So rationally, we will say yes, of course, it makes a sound, even if someone is there or not. But the scientific answer to this question is that actually no, it doesn't make a sound, because sound is something we call qualia. So sound is something that is created in our brain. It's not a concept, but it's a construct in our brain. We interpret the waves of air coming into our ears as sound. And it's the same. If we ask the question, is a apple green? I can draw it green a little bit here. Is an apple green? Well, the same goes there. Color is just reflection of light emitted from objects reaching our eyes, and our eyes are interpreting these light waves as color in our brain. So color it's not existing outside of our brains, it exists only inside of our brains. So this is also another example of qualia. And now the question was, are emotions real? They are not qualia, right? They're something else. So, but no, emotions are not something outside our brains either. So when we're looking, all these three questions is no, they are not objectively real. All these things, sounds, visions, or vision and feelings, they are all inside of our minds. They need an observer, and feelings also need an observer. For feelings need observer. If we're looking outside and looking at someone crying, we are decoding that person's facial expressions as sadness, right? Decoding out their experience. Or we're categorizing our inner experience, right? So we're feeling the feelings that come up from our interoceptive network about what's happening in our bodies. It's also categorizing our inner experience. But feelings, we feel and stuff, but emotions at the end are part of a social contract that we have together with supposed to be like a contract here, declaration here. So they are a social agreement. So we say when we cry we should be sad or very happy. We have decided this socially, and it's just together with these, because these agreements helps us to create the concepts, so we can share the concepts. So if I draw this object here, you don't know what it is. It could be anything. If I do this, you still maybe now you can guess what it is. I don't know. Let me do this. So now your control network is trying to decide what this is. It's now inside your brain. A lot of concepts are to the races and trying to win, but still there's no winner yet. Let's see if I do this. Maybe now you can see what it is. No, but if I do this and I do that, it's a bee. So it took some time, but you had to have some hints. Of course, this doesn't look like a bee, but we have some conceptual understanding of what it is. So this we can recognize with the help of concepts what I'm drawing, and it's the same with our feelings or emotions. We get some hints and we construct the concept in our mind, and then we recognize the feeling inside of us. So our brain is trying to detect what we're feeling, what the emotion is by using our concepts. And also these concepts are our brain is, since it consists of many concepts that we learn through our lives, we can say that our brain is actually not it's not only learning, it's actually being shaped by the concepts. So what connections goes on inside our mind, it's decided by our culture. So our brain is actually a cultural artifact. It's not only a biological machine, or so to speak. It's culturally it's culturally created. So to summarize what the functions of feelings is, it has 5 functions. One function of feelings is to create meaning to experience. It's also to give a response, so we can make a quick response, so we know how to act in a certain situation. So if we feel bad or feel angry in a situation, maybe we should withdraw, or we should scream. I don't know. So and also we have seen that it's also energy budgeting. So it's also to tell us with our effect what should we do So these are like the private meaning of a emotion. But we also have a social aspect to our feelings, is to communicate. So we want to express to others how we're feeling, and maybe expressing it through feelings is the best way instead of using words. But we can also do this to have influence on others. So by becoming angry, we can create fear in others so that they don't act in a certain way, or we can express happiness so we can so we can affect people in a positive way, want to encourage people to do something. We can show happiness for what they do. So social influence also. So these are the social aspects of feelings, and these are like the internal. So there's much more to say about this book, but I hope that I have triggered your curiosity on emotions and made you think about emotions, what they are, how they relate to concepts, how we actually can program our minds in different ways. This book has left me with a lot of questions and thoughts, how and explanations as well. So go ahead and read it if you felt you were intrigued by what I explained here, so you can learn for yourself. So this was just a review or summary. There's much more to it than what I'd explained here was just the first half of the book. In the second half, she goes into other questions like whether animals can have emotions and how we can control our emotions in better ways, and and also like a lot about other philosophical questions. But I just went through how the first part of the book. So I hope you enjoyed, and take care.